Hey everybody, it's Mr. N, and we are going to talk about logarithmic functions today. So let's go ahead and start with the definition. So here's a logarithm. The definition of a logarithm is a log base a of x equals y if and only if a to the y equals x. So the first and most basic question is, well, what the heck is a logarithm? So we know this definition, but what the heck does it do? Well, in math, we always have things that undo each other. So for addition, you have subtraction. Subtraction undoes addition and vice versa. For multiplication, you have division. So division undoes multiplication and vice versa. Then we've got something that we have that are exponents. So if you have something to the third power, so 3 to the fourth power, 2 to the fifth power. So something to a power, you need to undo it. Now, we can undo it by taking the root. So if I have, for example, here, 5, we'll say squared, right? To undo 25, I could take the square root of 25, and that'll give me 5. So this is 25 to the 1/2 power, which is the square root of 25. And we could go cube roots, we could do etc., etc. What if, though, your exponent was a variable? So what if you had 5 to the x power, and this equaled some random number 10? Okay, this is the situation that we want to try to undo. And that's where logarithms come in. So we have this definition, log base a of x equals y, if and only if a to the y equals x. So this is kind of what we have here. This situation, a to the y equals x. So for me to use the definition here, I would have to say log base 5 of 10 equals x, just by using my definition. Now you could think of it, put these in place, this triangle, the circle, and the square. Notice how it changes. So if this was my triangle, square, and circle, triangle, square, circle, then the triangle dips down. The circle is what ends up here, and the square is there. So you can make it visual by, instead of putting letters and numbers here, you could just put shapes and just see how the shapes end up. That's just one way of teaching it. But this is the basic definition. That is what helps me solve this, because we defined a logarithm to be the way we're going to undo the exponent. Just like we defined addition and subtraction. Subtraction is going to be the opposite of addition. Addition, you're giving something. Subtraction, you're taking it away. So that's the same situation. For exponents, we're raising it to a power. For logarithms, we're undoing that power. So then we have some special rules and laws for logarithms, and here are the rules and laws. The first one over here is the log base a of a to the x is just equal to x. In other words, the log base a. Well, now what am I talking about when I say base? So over here in my previous example, I had indicated that there's a base. Now this is my base. Over here is a, is my base. This was my base. This became my base. Now the base is like me saying base 10. So a logarithm with base 10 means we're going to use a base 10 system on it. Base 10 system means we're using our 10 fingers, right? That's why we use base 10, 10 fingers. We can have base 3, base 2, whatever. Binary is a very other one that's widely used because all computers work off a binary system. It's an on and off switch. The electrical current's either flowing or it's not, so it's either on or it's off. So there's two modes, 0 and 1, and it's binary. So all those use binary systems. But we will be using mainly base 10. So how do we convert this? Well, right here we know that if I have the log base a of a, since the base and the number are the same, those will undo each other and you're just left with x. Just like if I raise it to the power, a log base a of x, these two will undo each other and you're just left with the x. Here's where it gets really weird. The log base a of x times y. So if you're multiplying, you're adding the logarithms. Yeah, that's kind of so weird to say that. But when you're multiplying, you're adding the logarithm. So log base a of x to the y is log base a of x plus the log base a of y. Just like if you're dividing, you're subtracting them. What? Again, you got to go back and think of it like when you have 5 to the third power times 5 to the fourth power, you get 5 to the... What did you do to these powers? You added them. You're multiplying here these bases, so the bases are the same, but you're adding the power. That's the same kind of concept that goes with these logarithms, because we're dealing with exponents. And over here you have the log base a of x to the r. Here, this r will come out in front and make it a multiple of it. So the r will come out in front and make it a multiple of it. Now, I covered this super quick, and that's mainly because this is a calculus course, and this is typically just a review part of our course. But these are the basics, and you need to understand these. So if a is greater than 1, the function f of x equals log base a of x is 1 to 1. So if a is greater than 1, you know it's going to be 1 to 1 because of what a logarithm graph looks like. And here's what the logarithm graph will look like. Oops, let's undo that and use the right tool. And it looks like this. And you notice that it approaches the x-axis, or the y-axis, but never crosses it right here. So we can find the limits. The limit as x goes to infinity of log base a of x is equal to infinity, assuming a is greater than 1. If a is anything other than that, the graph will take on a different look. And the limit as x goes to 0 from the right, log base a of x equals negative infinity, which means as I get closer from the right side, it's going to go to negative infinity. That's the graph of it. Then we've got natural logs. Of course, over here, we knew what the natural base was, and we talked about it. That's Euler's number, which is e. And to undo e, we're going to use ln. That's the natural log. So that means the log base e right here of x that's just ln of x. So whenever I say log base e, instead of base 10, base 3, whatever number, if I use e, we're going to just do ln. And we use this because it seems to come out a little bit easier with our calculations. So instead of taking the log of something, we're going to take the natural log of something. It just works out a little bit better. So from above, ln x equals y, if and only if e to the y equals x. That's a definition. Ln e to the x equals x, because ln and e will undo each other, and e to the ln x is x because e to the ln undoes each other. That's just part of the rules of logarithms. And then we have ln e, which is just 1. The change of base formula allows us to take a logarithm with any base, make it base 10, so log base a of x is just log x over log a, and when I say log, that means it's going to be base 10. When I don't indicate the base, it's going to be base 10. Over here, ln x over ln a. That's the change of base. And also the limit as x goes to infinity of ln x equals infinity, and 0 from the right is negative infinity. The graph takes on a similar note. All right, let's do some examples. On this first example, we need to find the log base 2 of 16. So this is me asking you 2 to what power right here? What power would be 16? And that's what you're trying to solve there. So in this case, 2 to the fourth power would be 16. So this answer is 4. On the next one, 9 to what power would be 3? That's based on the definition. That's what we're using from our definition. And that would be 1/2. And finally, ln root e. This is like saying ln e to the 1/2 power. Ln e is just 1, so your answer here is 1/2. All right, moving on to our next set of problems. Okay, rewrite as a single logarithm. So we need to combine these. Since these are all base 10, this is going to make the process a lot easier. So to combine them, I know that I have to put this out in front first. All right, because I need these all to look just like log base number. And this is base 10, so I'm not worried about it. This is 2 to the fourth minus log base 10 of 3 plus log base 10 of 16. Now the subtraction tells me division, the addition tells me multiplication. So it's one massive log, and this is 2 to the fourth on top, divided by this 3 times the 16. That's how that works out. Now you can go ahead if you would like and say that this is 16 times 16 over 3, reduce it out, but I'm just going to leave it like this for our purposes. On the next one, let's take a look. Very similar over here, but I'm dealing with ln's, so I need to just keep it all in terms of ln, so this comes up here. So ln x plus 1, this is the rule that I can use that I could put this up top, so that would be squared. Plus, I'm going to do that again here, ln x to the 1/3 minus ln cosine x. All right, now I've got them all in the terms of just ln, and now I can do what I did before, ln, and then anything addition is multiplication, anything subtraction would be division. So this will be x plus 1 squared times x to the 1/3, all divided by cosine x, just like that. Moving on to the, let's see what we got. Solve each of these for x. Now I'm going to go ahead and use the definition that we talked about. Remember, log base b of x equals y, then b to the y equals x, or you could put anything you want here, triangle, circle, square, like I did that. So over here, this is going to tell me that 10 to the 3rd will be 1 plus x. So I end up with 1,000 equals 1 plus x, so x is 999. Okay, on the next one, we've got ln. So remember, ln is an e, that's the base of it, the natural, it's to undo the natural base, so that's what I'm going to do. I'm going to use e. So I'm going to take e to each of these powers. So e to the ln 1 over x, e to the negative 2. That will undo this and just give me 1 over x. On this side, I end up with e to the negative 2. So again, to undo ln, I use e. And now, solving for x, I'll get 1 over e to the negative 2 equals x, so those x is just e to the 2nd power. Okay, next problem. Let's see what we got over here. We've got ln 4x minus 3 ln x squared equals ln 2. Again, let's see if we can combine these two. And I'm going to put this out up here, so I'll have ln 4x minus ln x squared cubed equals ln 2. All right, over here, this is subtraction, so I can combine them with 1 ln, and I can say that this is 4x over x to the 6th equals ln 2. Now, notice they're both ln. Now, I could say e to this power, e to that power, and it'll get rid of them. But you could just take a look at this and say, oh yeah, I see what's going on here. This is just this. So set that equal to itself over here. And that's what we're going to do. So 4x over x to the 6th equals 2. This will reduce out with one of those to be 5 on the bottom. And then finishing this problem off, I will get 4 over 2 equals x to the 5th. So the 5th root of 2 is what x will be. All right, taking a look at the next one. Again, this is just a definition. So over here, I'll have log base 3 of 2 equals x. What if you wanted to do this with natural logs? You could say ln 3 to the x equals ln 2. Take the natural log of each side. And then you have x ln 3 equals ln 2. So x will be ln 2 over ln 3, just like that. And it's the same answer. Because I can use the change of base formula and say this is the log of 2 over the log of 3. But these are base 10s, these are base e's. It's the same exact thing. Okay, next, over here, e to the 3x equals 7 over 2. I'm going to divide each side by 2 first. Now, natural log each side, because that's how I get rid of the e. So that goes away, so I end up with 3x equals ln 7 over 2. So x will be 1/3 times ln 7 over 2. Or you can say ln 7 over 2 divided by 3. Works either way. Over here, let's take a look. I can take out an e to the x. So I will go ahead and do that. I take out that e to the x. I'm left with 1 minus 2x equals 0. So e to the x equals 0, and 1 minus 2x equals 0. Okay, on this side, I will get 1/2 equals x when you solve that. On this side, well, when will e to the x equal 0? It will never equal 0. If you look at the graph of it, it'll never equal 0. If you try taking the natural log of each side, ln 0, you can't do that. So this side is undefined. So your only answer is x equals 1/2. All right, so hopefully that wasn't too bad. Thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.